just follow along, hopefully with the convenience of the binder. And I hope that will minimize for the rest of the evening how many times our reporter needs to stop and mark pages. And I do apologize, Solicitor Finucci, that some of the exhibits in this binder are duplicative of documents that you entered on behalf of the board at the start of this proceeding. But better safe than sorry for both of us, I think. I'd like to ask at this time if Mr. John Nyland would please come up to the podium.
Mr. Nyland, make sure the mic is right.
My name is John Nyland, N-I-L-A-N-D. Yes.
Mr. Nyland, would you please state your title and affiliation?
My title is Director of Business Development for Invenergy.
And in that position, what is your role with the company?
My role is to go out and identify project development opportunities in a variety of power markets, including PJM.
What is PJM?
PJM is the independent system operator who controls the electric grid in this region, and it includes Pennsylvania, New Jersey, Maryland, Kentucky, and several other states. It's the largest independently controlled electric system in the United States.
Could you please describe your professional experience and background?
I am a mechanical engineer, and I've been in the power industry for over 30 years. Early on in my career, I was an engineer working on the design and construction of various power plants, including nuclear, coal, gas-fired, and integrated gas-fired combined cycle projects.
In connection with the application that's the subject of this hearing, did you submit a declaration?
Yes, I did.
If I could ask you to turn to Exhibit A1. And to Exhibit I of Exhibit A1. I think it's easiest if you start from the back of that exhibit.
The back?
From the back, it's about a dozen pages or so from the back.
Yeah.
Is that the declaration that you provided?
Yes, it is.
And attached to that is a CV of yours, is that right?
Yes, it is.
What sorts of power projects have you been involved with in your career?
Early on in my career, as I indicated earlier, I was involved in the design and construction of a nuclear plant. That was Beaver Valley Unit 2, just outside of Pittsburgh in Shippingport, Pennsylvania. For that project, I was actually responsible for the design and construction support of the secondary side, which was everything in the turbine building, from main seam isolation valve all the way up into condensate polishing, steam turbine, all the way up to the feed water isolation valve, which was sort of the boundary between the non-safety and safety-related side of the system. After that project, I moved on to a project in Texas, in HP Unit 1, and there I actually lived in Texas and was responsible for managing the startup engineering support group. That was a group of about 50 engineers, and we were going through startup testing and responding to various construction issues that were raised during that process. After that, I relocated to Virginia. I lived in Richmond. I was working on a seconded basis for Dominion, helping to support project engineering services at their nuclear units, North Anna and Surrey. Thereafter, I went into business development. This is all for an engineering firm called Stone & Webster, which no longer exists, but doing business development activities for them. For the most part, that was in the Far East, in China, Japan, in Vietnam, and Thailand. And there was involved in a variety of projects to bid EPC turnkey processes and also provide engineering services to folks like the People's Republic of China and the Korea Atomic Energy Research Institute. At that point in time, that would probably finish up to around 1998. Continuing to do bid projects, the power market in the U.S. started to recover a little bit, and I was involved in a bid process to construct a combined cycle plant in Rumford, Maine. We won that process, and I volunteered to become the project engineering manager. And as a result of winning that project, we actually got a second project from that particular owner. It's a company called EMI. And I was in charge of the design and construction support of two F-class combined cycle projects being constructed simultaneously, one in Rumford, Maine, and the other one in Tiverton, Rhode Island. As a result of that involvement in those projects, the projects were, during the course of construction, Calpine acquired 50% interest in the project, and I ran the monthly meetings, and Calpine offered me a position with their company to do project development support and engineering support in their Boston office. I went to work for Calpine. I worked for Calpine for approximately 7 or 8 years, and at my role at Calpine was doing similar activities as to what I'm doing here with Invenergy, and that was identifying project sites and going out and trying to develop power projects. Those were mostly located in the Eastern Interconnect, which is everywhere east of the Mississippi River, including Ontario. I was involved in 7 or 8 projects, probably representing somewhere over 5,000 megawatts. Those were all combined cycle projects. Calpine, unfortunately, when I was there, they declared bankruptcy. I was approached by NRG, and I became a vice president for them to do similar activities in their Northeast region. That was my principal area of focus was in New England, in Connecticut and Massachusetts, and we were involved in developing not only peaking projects, but attempting to try to develop a process called integrated gas-fired combined cycle projects. That was in the 2007-2008 timeframe. My tenure with them was rather short. From there, I went to work for a small startup company called Breakpoint Energy. They were attempting to commercialize a catalytic coal gasification process that would have taken coal and converted it directly into pipeline quality natural gas. That process was, although it didn't quite necessarily work out for them, I did that for about a year. I developed a pilot scale facility for them that was actually constructed in Massachusetts at the Breaking Point station that was then owned by Dominion. And I worked for them for about a year. And after that, I joined a small startup company that was focused on similar development activities. And that company was called Curative Resources. And we developed a project that was called Bayonne Energy Center. That was a 512 megawatt project using simple cycle technology located in Bayonne, New Jersey, that was directly interconnected to the New York Zone J grid via submarine cable that we installed across New York Harbor. Worked for them for a number of years. We attempted to do further development, but this was probably during the time when the economic downturn occurred, so it became somewhat problematic to raise capital. And then about a year and a half ago, I joined Invenergy to do project development services. I was brought into this project somewhat as an independent observer to look at how the project development had happened and taken place, and to lend some experience and guidance to the degree that I could.
Thank you. During your description of experience, there were a few terms that you used that I'd ask if you could describe. So the first one, which is applicable here directly, is combined cycle. What is combined cycle?
Combined cycle is a term that we use to describe a power generation technique that uses a combustion turbine in combination with a steam turbine. And effectively what happens there is you have a combustion turbine, which is a gas turbine, very similar to a jet engine that you would see on an airplane. That engine is connected to a generator, and then what we do is we take the exhaust from that machine, which is very hot, and we pass it to a boiler to generate steam. That steam is passed to a steam turbine, hence the combined nature of it. And as a result of that, it's really the most efficient way to produce electric power that we know today.
And how does that compare to simple cycle?
A simple cycle power generator is only a gas turbine just by itself. Its exhaust is hot and it's vented into the atmosphere. You use simple cycle gas turbines in situations where you need to be able to provide a peak load support, typically in a load pocket, in an area like in a city, for example, like the Bayonne Energy Center I mentioned earlier. That was a peaking operation. Trying to get power directly into Manhattan. Typically you try to locate those facilities in situations like that. The combined cycle projects are more of a base-loaded project, so they don't necessarily have to be located, near a population center like a city or what have you, and they can be located somewhere else on the grid. Typically, at higher voltage interconnections, like in the case of this project, which would be connected to a 345 kV system.
Would you please describe in general the project that Lackawanna Energy Center LLC proposes to build?
Lackawanna Energy Center is a combined cycle project. It consists of 3 combustion turbines and 1 steam turbine. The technology that we're using for the combustion turbine is manufactured by General Electric. It is a new technology for General Electric. It's sort of the next phase of technology. They call it an H class. We provide letter designations. The industry provides letter designations for these size units. They call them frame units. And this latest technology that they have, they call the HA.02. Each combustion turbine has the ability to produce approximately 330 megawatts. And when you put it in a combined cycle operation, its efficiency is roughly 62%, or said another way, the heat rate of that unit is around 6,400 BTU per kilowatt hour, which is the highest efficiency of any power generator of any type.
So durable power that would be produced by this project.
Yeah, the power goes into the grid. It will be, the facility will be interconnected into a 345 kV, 345,000 kilovolt transmission network. The interjection of that power is controlled by the ISO, the independent system operator. They will control the dispatch of the plant. Once the power gets into the grid, it really sort of, goes to wherever the load is, right? I mean, that's the nature of the electricity. You can't really, dictate where it's going to go. It's going to go to meet whatever load is out there for it to be. The thing that's interesting about the power industry is that the generation really must match the load exactly. And that's one of the main functions of the ISO, is to control that generation so that it always matches the load. Because if it doesn't quite match the load, then the frequency can be off. It could be 59 hertz as opposed to 60 hertz. The voltage may vary, and when you have that situation, you see things like the lights will dim, or you'll have a brownout, or a blackout, or something like that.
Is the capacity of this proposed plant comparable to other projects in existing in Pennsylvania?
It is. As I said earlier, the combustion turbines, because, this new technology, they produce so much power, it's higher than what you would typically see in a what we call a 3x1, 3 gas turbines, 1 steam turbine configuration. Just a few years ago, that type of configuration would have only produced somewhere between 750 to perhaps 1,000 megawatts, and now we're, encroaching on 1,500 megawatts, and that's really due to the fact that the combustion turbine performance has been improved, that much. So I think if you were to canvass the power industry, especially here, even in Pennsylvania, you would see that there are a number of combined cycle projects that consist of 3 combustion turbines and 1 steam turbine.
For the project that you are proposing, where is the access to the gas supply?
The project will interconnect with a gas pipeline that is owned by UGI, and it's right on the border, and they may even, transect the site at some point, so it's pretty much right on site.
And where is the transmission line that would take away the electricity?
The transmission line is close by the site. PP&L will be, bringing a circuit over to interconnect with the switchyard that will be built on site.
How would you describe the type or class of power project that's being proposed here?
I would classify this as a base load project because of its low, its high efficiency, its low heat rate. This project will be dispatched in a base load fashion. And what that means, it's pretty much going to operate all the time. When you look at the power industry, what you want to see in a base load unit is that it's able to produce energy at the lowest possible cost. And because this facility has, the best heat rate, the highest efficiency, it will be able to do that. So it'll be a base load unit. PJM, the way the unit will operate within the market is it will be bidding in on a day-ahead basis. We'll be able to bid a price, based on our heat rate and the other operational characteristics of the unit, and PJM will be able to accept that bid, and it'll be running all the time.
How does that compare or contrast to other types or classes of power generation plants that exist?
Well, if we're just talking gas-fired plants, the other class of facility would be a peaking facility, which, we like to use the term capacity factor. And the capacity factor of this unit, 100% means it's running 24/7, right? So, because there's some time when you have to have the unit down for maintenance or what have you, it's probably going to have a capacity factor in the high 90s. A peaking facility, like a combustion turbine operating in a peaking mode, would really only be operating probably less than 30% of the time, because the function of that facility, number one, it's more expensive to operate. So the daily cycle of power, the load that you see every day, the price for that power sort of follows it. As the load goes up, the price generally goes up too. It sends a price signal to the industry that you need to have more expensive resources online in order to meet that load, and this is all coordinated by the ISO. On probably a rolling 15-second average, they're sending signals out to have either new assets turn on or turn off, as the case may be. And so, the peaking project, generally, because it's more expensive to operate, they would only be there for the peak day, hence its name, that it would operate during the peak part of the day.
You mentioned ISO. Once again, what does ISO mean?
Independent System Operator.
And in this region, who's that?